Hello my dear students. In this video we are going to discuss about a topic due to which we can say existence of life and everything is possible on this earth. The name of the chapter is Gravitation, a very important chapter in science book. Let's discuss about the history of gravitation or gravitational force, how we came to know about it. It is the story of a great scientist Sir Isaac Newton. When he saw a falling apple, he started thinking why apples falls down, why does not go in upward direction. He experimented a lot on different objects and finally published a theory of gravity in 1687. According to him, gravitation is the force of attraction between two objects in the universe. He said every object applies an attractive force on every other object. Here in this example we can see it that the earth applies a force on apples. We all know that when we apply an unbalanced force on any object, the acceleration is produced in that object due to the force. This force of attraction which is applied by the earth on any object is called force of gravity. Dear students, now we discuss some facts about gravitational force. We know that electrostatic and magnetic force applies attractive as well as repulsive force on the objects. It means if same charges are there, then the force of repulsion will be applied, and if unlike charges are there, then force of attraction is applied. But in case of gravitation, always attractive force is applied. It is always applied between the centers of two objects. Center of object is basically considered a point in the object from where the object can be balanced. The gravitational force depends upon the size of mass of the objects. If objects are very heavier, then gravitational force can be observed. For example, in case of earth and other objects, and if the mass of the object is very less, then it is almost negligible. For example, gravitational force between humans. Dear students, we all know that moon revolves around earth. Do we know why it revolves? Why does not it go anywhere? It always moves around the earth in a circular orbit. The reason is that the earth applies a force of attraction that is called gravity on moon. In case of circular motion, this force of gravity is called centripetal force. Here in this picture you can see that the tangent, which is a straight line touching the circle externally at a point, denotes the direction of velocity of the object. So now we can define centripetal force as a force when a body undergoes circular motion. It experiences a force that acts towards the center of the circle. This center seeking force is called a centripetal force. If we remove the centripetal force between earth and moon, then moon will continue to travel in a straight line path which is tangential to its orbit around earth. Now we discuss about a very important law given by Sir Isaac Newton in 1687 about the force of attraction between the objects in the universe, which is known as Newton's law of gravitation. According to this law, every object in the universe attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Now we derive a formula of force of attraction with the help of this law. Let us consider that we have two objects of masses capital M and small m, as we can also see in the picture. Now if we consider force Bf, then according to universal law of gravitation, we can write F is directly proportional to m into m, and F is inversely proportional to 1 by R square. So if we combine it, then we can write F directly proportional to M into M by R square. Now for removing the proportionality constant, we introduce a constant which is capital G here. So we can write F equals to G into capital M into small m by R square. Here G is the constant which is known as universal gravitational constant, and its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. In last we discussed about some facts of universal gravitational constant. This value of G was found by Henry Cavendish. Its SI unit is Newton meter square per kg square. How do we get this value? So as we can write the formula G equals to F into R square by capital M into small m. Now as we all know that the SI unit of force is Newton and the SI unit of distance is meter, while the SI unit of mass is kg. So if we put the SI units of all these terms, then we get G equals to Newton meter square per kg. Since we don't have any direction, we have only magnitude of this gravitational constant, so it's a scalar quantity. Its value is same or constant throughout the universe. Dear students, I believe you all have understood these points clearly. So if you have not subscribed the Alam Academy, subscribe it and like this video. Thank you very much.